టీ తాగాను వాటర్ బాటిల్. ఫుల్ స్క్రీన్ నాకు అది కూడా రైటింగ్ అది కూడా కావాలి. దాని ఓవర్లాప్ రాదా పీపీటీ మీద? మారారు, అది మారిందా ఇది? ఇంతకుముందు వేరే ఉండే. ఓకే. వైట్ కావాలంటే ఒక నిమిషం, ఏ కలర్ పెడదామని చూస్తున్నాం. క్లియర్ ఇది ఇదా? Yeah, good morning. Which you are studying now? Is it required mic? అలా కావాలి లైవ్. ఓకే. In the first year, you studied the one subject, that is the BEEE, right? So in that the BEEE, two parts, one is the electronic part and the electrical part, right? In the electronics part, you studied already the number systems, that is the digital logic design. Okay, digital concepts. Okay. In first year, what are the programming languages you are having? C language, data structures. Okay. Any hardware labs, IT workshop or IT workshop? Okay. In IT workshop, what are the concepts you studied? Tell me the, briefly. Just I'm not asking the elaborate. What are the concepts or syllabus? or what are the experiments you are having in the IT workshop? You are dismantling your CPU, right? So what are the components or hardware blocks you find out in that? ఏమేమి ఫైండ్ అవుట్ చేశారు? ఏమేమి ఉన్నాయి అందులో? సిపిలు ఏమేమి ఉంటాయి? ప్రాసెసర్. ఓకే. నెక్స్ట్ keyboard, mouse. Okay. Then coming to the monitor. Okay. Now coming to the CPU motherboard. In motherboard, what are the blocks are present? ఏమేమి ఉంటాయి motherboard లో? Motherboard is not the single unit. That is a collection of blocks. ఏమేమి ఉన్నాయి? ఏముంటాయి motherboard లో? Okay, CPU. Okay, that is a central processing unit. Okay, in the CPU, what is the purpose of CPU? What that will do? CPU, central processing unit. What is the functionality of that CPU? Okay, coming to the programming languages, you study the C and data structures, right? The C language, CP, and data structures, DS. In C language, the basic program you written, that is the addition of the two numbers, right? That is only the basic program for the first program. After studying the introduction to C language, what are the data types and different keywords. After that, immediately you are writing the program with the one program, that is the addition of the two numbers. Okay. Now, so how you are writing the program? You are starting the program, right? Then you are initializing the values, numbers, assigning the values to the variables. Before assigning the variables to the numbers to the variables, first we are defining the variable type. What is the variable types? Integer, long, char, character, integer, double integer, float. So first we are defining that variable names under data types. Then we are assigning the suitable value. If you are defining the a, for example, you can take the variable as a as the integer, right? Integer. So then further you can assign a is the integer, then a is equal to 2 or 3 or any numeric value, right? That is the limited to integer. Anybody can tell me the integer size? 4 bytes. Okay, what is the meaning of byte? Bits. Yeah, bits. Collection of bits. How many? What is the amount of that collection? 1 byte. 8 bits. 8 bits is equal to 1 byte. 16 bits is equal to 2 bytes. That is also called word. Right? The 32 bits, double word. Or simply that is called the quad also. Okay. So now, if you are assigning the variable as a integer type, you can consider the integer only. Character means assign the characters, names, like that, strings. Okay. For example, A is the character. If you are defining the A is a character, then I'm assigning the value or value to that variable. A is the character. is defined as to represent the numeric value using symbols. Based on that symbols, the different number systems we are having. The first one is the decimal number system. You know the decimal number system? Okay. So in the decimal number system, the any value can be represented using the 9 different symbols. The 10, including 0, the 10 different symbols. The 10 different symbols are 0, 1, 2, 3, up to 9. If you want to if you want to write the value, that is the 257, again the same symbols we are using, 2, 5, 7. If you want to write the 9,000 change, that is the 900 and 200 and 9,000 and 259. Same numbers, the same symbols. Okay. Based on the number of symbols, we're having the different number systems. One is the decimal number system, that is having the symbols are 10. So the base value of that number system is 10. The base value is 10. And the different symbols are 0 to 9. The next immediate number system is binary. That binary is having the by stands for 2. The 2 means only the two different symbols we are having, that is the 0 and 1s. The zeros and 1s. Slides in your. So the first part of the first unit is having the binary numbers and number representations, then base conversions. No, like, చేది ఇంకా అప్లై చేసుకుంటాను. ఉంది ఎట్లా మరి? ఓకే. The number system and system of writing numbers use set of symbols. Number system is a method of writing the numbers using called the numbers. Because it is having the 10 different symbols. the 10 different symbols, that is 0 to 9. And this can be represented as suffix 10. The suffix 10 means that is that decimal number system. The next binary number system is having the different for zeros and ones only. The any large or small numbers can be represented using only the zero and ones only. So that is called the binary number system, and the base value is 2. How we are saying the base value? Depending on the number of symbols present in that number system. The octal, this, yeah. On the decimal number system, the 0, 9 and A to F. Here, the A to F are not characters. The A to F are numbers in the hexadecimal number system. The hexadecimal, they have that 16 decimals, that is 0 to 10 of 6. The total 16 symbols. Now, in this different number systems, and here this base value is also called okay, the radix is denoted as the R or uh, okay, so the 10 equal to 2, R is equal to 8 and R equal to 16. Now, the any can answer what is the maximum symbol in the decimal? 9. Okay, good. What is the maximum symbol value in hexadecimal? What is the maximum symbol in symbol value? The first What A? 10 base 8. Okay? So 250, that is at 6 into 10 power 0. 15, 6 is decimal number. Decimal base is, hmm, okay. Then the 256 we are representing the weights The what is the 6 is called 256? What is the 6? Units. Ones place or units. Ones place. What is the 5? Tens. And 2 is the 200. Okay. So now the units are placed. Its place can be written as 6 into 10 power 0. What is the 10 power 0 value? 1 power 0, 50 power 0, 1 only. The any value, the power is 0, that value is 1 only. Okay. So now the expansion of that 256 is the 6 into 10 power 0 plus 5 into 50 can be written as 5 into 100. 5 into 10 means 5 into 10 power 1. What is the 10 power 1? Next, plus the 200. That written as 2 into power, right? So that is a this is the 10 0, 10 power 1 and 10 power 2 and 10 power 3 and so on are called the positional states or if okay. So if the number is the base decimal number, then you can represent that value, that number in the positional weights. That is 10 to the powers. If you are writing the binary number system, then the positional weight should be in terms of what? Decimal number system. What are the positional weights? 10 power 0, 10 power 1, 10 power 2, 10 power 3, and 10 power x. Anyway. Now coming to the binary values, what is the positional weights? 2 to the powers. The positional weight should be right in terms of base powers. Base of that number system. Okay. So now any number can be represented as this. For example, the 278. That can be written as the different symbols are 0 to 9. That can be written as the 200, 2 into 10 square plus 7 into 10 power. That is the ones place, tens place, and the 100. The usual or the of the decimal number is A0 is the multiplication factor in that position, and base value is 10 power 0. Power 0. That means 8 into r power 0, r power 1, r power n minus 1, and r power n are called the positional weights. Positional weight. Next. So after the same representations, you can remember for the remaining other number systems also. Then next we can study the number conversions. How we can convert the one number system to another number system. లేదమ్మా పెన్ లేదా చేతోనే రాయాలా మీ స్క్రీన్ అంటే మీ స్క్రీన్ ఏమన్నా సరే మీ ల్యాప్టాప్ అంతవరకు చూడండి మినిమైజ్ చేసేస్తాను ఇంకా తీసేయమంకా ఆ స్క్రీన్ వాడుకుంటాను number conversions. number conversions. Okay. The first one is, so we know the decimal numbers. The decimal numbers are base is 10 and this base is having the symbols are 0 to 9. 0 to 9 symbols. Now, we are going to convert decimal to binary. Decimal to binary number system. Okay. So, in decimal to binary number systems, here the base value is 10 and base value is 2. Okay. So, to convert the decimal to binary numbers, first, here, this is called source and this is called destination, right? That means the input. These are called input and this one is out. So, we know the number is the decimal number. That equivalent to binary value we need to find. So, in this case, first you can divide with, resultant base value. You can divide the decimal number with resultant to base value. What is the resultant base? Binary value. The binary base is 2. So now you can divide with 2 until to get 0. Until the coefficient should be 0. If the coefficient is 0, then you can stop the procedure. After getting the 0, after stopping the division process, then you can arrange all remainders from bottom to top, right? This procedure can be applicable to any number system, from decimal to any number system. 6, divide with the resultant base value and then until to get the 0. Whenever the coefficient is 0, then you can stop the procedure. So in this division process, write the remainders separately. How much remainder is present? For example, the 5 divided by 2. What is the remainder? 1. That remainders you can write separately. After getting the coefficient is 0, then arrange all remainders from bottom to top. Bottom to top. So that gives the equivalent value for the decimal number system. So if you are using the binary, then you can divide with 2. Then all remainders you can write from bottom to top. Now, if the simple number will take 25 is the decimal number system and right, convert the 25 to binary number. The 25 decimal number to binary equivalent value. So what is the procedure? Now you can divide with 2. The resultant number system is the binary. That binary base value is 2. So you can write the equivalent value. So what is the first procedure? Then you can divide with, how you can divide the normal division process, or take the LCM type. Or you can take the normal division process also. Normal division process means divided by 2 and write the remainder. What is the remainder value here? Remainder is 1. What is the coefficient here? 12. Ante kada? 2 12 ja 25. That 24. 25 minus 24, 1. Remainder is 1. Again, you can divide with 2 and the remainder is 0. Then what is the coefficient here? 6 divided by 2 and here the remainder is 0, and 3 divided by 2 and the remainder is 1. Then 1 divided by 2. Remainder is 1. And ఇక్కడ coefficient 0 రావాలన్నాను. So what is the remainder? 1. What is the remainder? 1 ని 2 తో డివైడ్ చేస్తే what is the coefficient and what is the remainder value? Coefficient is 0. The remainder value is 1. So now the coefficient is 0. Now with all remainders, you bottom to ఎక్కడ ఇది అనుకుంటా ఇది కదా 0/2 0 అది ఇక్కడ అవసరం లేదు ఇక్కడ ఇది క్యాన్సిల్ చేసేయచ్చు ఎందుకంటే మనం we got the coefficient is 0. Okay, now arrange the all remainders from what is the first one 1 this 1 0 0 1. So now you can write like this. So the equivalent value is 1 1 0 0 1. Okay. So the 25 decimal equivalent, the binary value is 1 1 0 0 1. Same number can be written as like this. Like this. This is the easy one. You can use this one. Okay. So 2 equals the what is the remainder? You can write the remainder like this. Again, the coefficient is not equal to 0. Then you can write with 6. The remainder is 0. Next, 2. The coefficient is 3 and the remainder is 0. Then 2. Right? మీరు ఇక్కడ డివిజన్ ప్రాసెస్ అప్పుడు బాటమ్ here 1 correct. Okay, so now you can all you think one also no issue, there is no problem. So what is the value 0 1 1 0 0 1 is the binary equivalent for given decimal value. Okay, now it find the equivalent binary value find out 126 126 26. Do it in that notebook. This is the basic conversion. If you understood this conversion, the remaining all conversions are easy. Up to the user defined number system also. Correct. 6110 is correct. Okay. Now, one more point is there. 25 is the decimal value. What is the value? 25. What is the value? You observed from this? Observation. If you are adding the 0 at the right hand side, the value will increase by 10 times in decimal. If you're adding 0 to the left hand side, the 0 will be nullified. There is no change. Okay? The same thing, don't write the zeros here, the value remains same in the binary also. So you can add the how many zeros here. Why I am putting this point here? Okay, 25. How many bits are present in the 25? Actual bits. The binary equivalent value 1 1 1 1 0 0 1. How many bits? 5 bits. 5 bits. So now you can represent the decimal number 25 in binary in 8-bit format. మనకు 25 ఈక్వలెంట్ బైనరీ నెంబర్ రాస్తే ఎన్ని బిట్స్ వచ్చాయి? 1 1 0 0 1. అంటే 5 బిట్స్ మాత్రమే వచ్చాయి. బట్ నాకు అందులో 8 బిట్స్ కావాలి అంటున్నాను. 8 బిట్స్ కావాలంటే ఏం చేయాలి? జీరోస్ యాడ్ చేయాలి. సో వేర్ యూ కెన్ యాడ్ ద జీరోస్? లెఫ్ట్ హ్యాండ్ సైడ్, ద సిమిలర్ టు డెసిమల్ నంబర్స్. This is applicable for all number systems. If the number is the integer, if you are adding the left hand side, the value remains same. Simply we are increasing the size. అంటే size అంటే ఏంటి? దాని value కాదు. Only number of bits we are increasing. But the value is the remain same. If you are here 5, then the 1, 2, 3, 4, 5, 6, 7, 8. Total ఎంత? 8 bits ఉన్నాయి. So this is the 8-bit format. Why you are representing the 8-bit format? In the digital integer, double, float, like that only. The integer ante 2 bytes. Double 4 bytes. Float fraction values also, including fraction value. That is the 2.5, 4.5, 2.6, 2.2. The 0.2 is the fractional value and 2 is the integer values. Okay. So now, the any number can be represented in the 8-bit format or 16-bit format or 32-bit format. That simply that is the 2 to the powers. 2 to the మీకు ఇంటీజర్ సైజ్ ఎంత? 16-bit అనుకోండి ఫర్ ఎగ్జాంపుల్. డబుల్ సైజ్ ఎంత? 32. డబుల్ క్వాడ్ 64-bit. సో ఇన్ దట్ కేస్ ఫస్ట్ 16 into 2 32 into 2 64. అంటే multiples of 2 or 2 to the powers we are saying, because all the digital computers are operating using binary numbers. The binary base is 2. Okay, so because of that, this the 2 to the power, that is the 8-bit, 16-bit, 32-bit. There is no 24-bit. There is no 48-bit. Okay, that is also multiply of 2 only, but that is not the 2 to the power. The 48 is not the 2 to the power. 24 also not the 2 to the power. The 8 is the 2 to the power. That is the 2 cube. The 16 can be written as 2 to the power 4. The 32 can be written as 2 to the power 5. That 64 can be written as 2 to the power, the 128, 2 to the power 7, 256, the 2 to the power 8, like that. So that's why we are saying only the 2 to the power, because of binary number systems only. Next. So the decimal to binary over. Now we need to understand the reverse way. Binary to decimal. In the binary, decimal to binary, what is the procedure to find? What's the procedure? Division process. You can use the repetitive division until the coefficient is 0. If the coefficient is 0, then you can stop the division process. Then you can arrange all remainders in bottom to top. So in the reverse way, we are writing here binary to decimal. Okay. Now the same number will take 1, 1, 0, 0, 1. Simple number. This is the base number, and find the equivalent decimal value. To find any number system to the decimal is the common procedure. Multiply with positional weight, and ఇక్కడ ఏముంది మల్టిప్లై విత్ ఆల్ పొజిషనల్ వెయిట్స్ అంటే ఇక్కడ ఏంటి ప్రోడక్ట్స్ సమ్ ఆల్ products sum all products, so that will give the, and this will give the decimal equivalent to value. Decimal equivalent to value, right? So this is the, and here multiply with the positional weights of using base. Okay, multiply with positional weight, that is the base. Okay, here what is the number we are taking? 1, 1, 0, 0, 1. Anybody tell me the positional weights for that binary number system? What is the positional weight? If you are writing here the 126, okay? So in this 126, this positional weight is 100, and this positional weight is 10, and this positional weight is 1s. And this can be written as 10 square, and this can be written as 10 power 1, and this can be written as 10 to the power 0. What's the 10 here? What is the 10? Base of number system. If you are writing the binary number system, what is the base? 2. So now you can represent the each number, each digit of the binary number system, the positional weight in terms of the 2 to the power. What is the first one to positional weight? 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. How many digits, how many bits in the binary? 5 bits. What is the maximum positional weight? 2 to the power 4. Means this can be written as the 2 to the power r minus. What is the r? Sorry. N minus 1. So this, how many bits in the binary? How many bits here? Here, 5 bits. So that means that is called n equal to 5. So the maximum positional weight of that number system is n minus power law, not bottom. Base law kadamma idi power law. 2 to the power n. So how many number system? So that is n is equal to 3. So the maximum positional weight of decimal is 10 power minus 10 to the power 3 minus, that is 3 minus the 200. Okay. Now for two decimal number system, we are following procedure. Can multiply with the positional weights of the each digit in the binary, then sum all products. That result is gives the equivalent to decimal value. So you can remember the 3 procedure, 3 points to convert the binary to decimal. For example, if you want to convert the octal to decimal, same procedure. What is the octal base? 8. Binary. For example, 8, 0, 8 power 3, 8 power 4, and so on up to. How many digits are there? You can that many positional weights. Okay. Power 0 plus 0 into 2 to the power 2. 1 into 2 plus 1 into 2 to the. Then you can do products and sum the all products. That will give the decimal value for the any number, not only the binary, any number system. And written as you already in the 2 1 or 2 2. So, what is the LSB stands for? Least least symbol base. What is MSB? Maximum symbol base. Here the B is stands for bit. Now can tell me symbol also wrong. The significant, the least significant bit and most significant. Least means value. Significant అంటే ఏంటి ఇక్కడ వాల్యూ అంటే దానికి మనం సిగ్నిఫికెంట్ ఎంత ఇస్తున్నాం అనేది ఎంత వాల్యూ ఇస్తున్నాం అనేది. సో దిస్ ఈస్ లీస్ట్ కరెక్ట్ లీస్ట్ సిగ్నిఫికెంట్ బిట్. If you are a computer science, always write the bit. What is the bit spelling? BIT. The BIT lo bit should be అది ఎక్కడొచ్చినా బిట్ అనే వర్డ్ ఎక్కడొచ్చినా కానీ యూ కెన్ రైట్ ద బిట్ బి షుడ్ బి నౌ అండ్ వీఆర్ రిప్రజెంటింగ్ స్మాల్ బి. మీ ఇంకో ఆప్షన్ కూడా ద క్యాపిటల్ బి కెన్ బి యూజ్డ్ టు రిప్రజెంట్ ద బైట్ మీన్స్ the people can treat as a byte. అంటే ఒక బిట్ ప్లేస్లో వాళ్ళు ఇంకా రిమైన్ బిట్ 7 యాడ్ చేసి దాన్ని బైట్ అంటారు. సో డోంట్ రిప్రజెంట్ ద బిట్ విత్ క్యాపిటల్ బి. హియర్ ద ఈస్ బి అండ్ బైట్. ఎప్పుడన్నా మీకు మొబైల్ ఫోన్ కదా 16 GB అన్న ఆ జీబీ తర్వాత బిని ఎప్పుడైనా స్మాల్ లెటర్ చేసిన మీకు ప్రాసెసర్ స్పెసిఫికేషన్ చూడండి. దాంట్లో ర్యామ్ సైజ్ 16 GB అంటారు. ఆ జీబీలో బి ఇస్ ద క్యాపిటల్ ఉంటుంది. క్యాపిటల్ మీన్స్ బైట్. ఒకవేళ స్మాల్ బి ఉంది అనుకోండి బిట్ అది. ఓకే, సో దట్ ఈస్ ద 16 GB. G stands for giga. Giga, what is the giga value? 1000 kilo. 1000 అంటే ఎంత? 10 power 3. 10 power 3 తర్వాత 10 power 6. 10 power 6 byte mega. Mega 10 power 9 giga. 10 to the power 12 tera. ఓకే, టీబీ అంటాం కదా. ఇప్పుడు వచ్చే హార్డ్ డిస్క్లు ఎస్ఎస్డీలు అన్ని టీబీలోనే. ఓకే, సో ఫర్ 1 byte and bit can be represented as small b and byte can be represented as a capital B. Okay, coming to our topic, the conversion of binary to decimal. Now okay, now what is the SB? 1 into 10 power, sorry, 1 into 10 power 0 to the power 0 plus next bit 0 into 2 to the power 1 plus 0 into 2 to the power 2 plus 1 into 10 to the 2 to the power 3 plus 1 into 2 to the power 4. And the any positional not weight, this is called the positional value. 1, 0, 0, 1, 1. These are the positional value. The any positional value is 0, don't ignore that positional value. You can multiply that positional 0 value into its positional weight. This to the power positional weight, ignore the 0 into 2 the 2 square. If you are ignoring this, then you can ignore the 2 square also. Ignore చేస్తే రెండింటిని ఇగ్నోర్ చేయాలి. పొజిషనల్ weight. What is the product to the power 0 value ఎంత? 0 into something 0 plus 0 into something 0 plus 2 to the power 3 8 into 1 8 plus and 16. Now we can add this all. 6 plus 8 24 25 is the, so this 25 base 10. Now do for the 1 1 1 1 1 1 1 0 equivalent decimal value 5. The second, do it, you know the value into procedure we have to know. One 120, same procedure. You can multiply with each positional weight of binary. Then you can do the product, then add the all products, then you will get the decimal equivalent value. Okay, that is the binary to decimal conversion and decimal to binary conversion. Everyone should know this procedure. If you know these two procedure, that is a decimal, the remaining can able to understand and you can able to write the equivalent value of number systems. And here we are not defining the any user defined number systems. The computer defined number system, that is the octal. What is the octal? Base is 8. The 8 can be written as in terms of the power is 2 cube and 16 to the power 4. Okay. So now okay. Now shall we go for the which conversion? Select I think you already studied the decimal to octal. ఎలా చేస్తారు? You can tell me the procedure. How to convert the decimal to octal number? Divide with 8. And you can write the remainders from bottom to top. That gives the equivalent to octal value. So, okay. Next, hexadecimal, divide with 16. The decimal number can be divided with the 16, and you can write the remainder separately. After getting the zero coefficient, then you can arrange all remainders from bottom to top. Okay, then that will give the equivalent hexadecimal value. Now, anybody can tell me the one example value of octal number? అది మీరు చెప్తే నేను క్లోజ్ చేద్దాం. సో octal conversion is not required. One value. 120, 125 is the octal value. Then 129 also octal value, right? అవునా కదా? బేస్ ఎంత ఉంటే అదే వాల్యూ, కరెక్ట్? ఓకే. వాట్ ఈస్ ద మ్యాక్సిమం సింబల్ ఇన్ ద octal number system? 7. బట్ మ్యాక్సిమం సింబల్ ఏది ఉంది అక్కడ? అదే రాంగ్. సో వాట్ బేస్ 8 ఇచ్చినంత మాత్రాన దట్ నాట్ బిలాంగ్స్ టు octal number system. You have to observe the what are the symbols are present. మీకు 127 ఇచ్చి octal number అంటే బ్లైండ్గా మనం ఓకే చేయొచ్చు. ఎందుకంటే ఇది 1 is the octal value, octal symbol, 2 also, and 7 also octal symbol. So therefore the given value is octal value only. But 128, 129 is not octal values because the 8 is not, or 9 is not belongs to the octal symbol. So అది ఎప్పుడైనా మిమ్మల్ని కన్ఫ్యూజ్ చేయడానికి అడిగితే సింప్లీ one word answer, that is not belongs to the octal value because the 9 is not the symbol of octal value. I can say this is the hexadecimal value. Is it correct or wrong? Yes. One hexadecimal value. Well, yeah. But the decimal value. Okay. But if you are giving this number, if you are typing this number in your programming languages or uh, in computers, that will give the error. అది నంబరా క్యారెక్టర్ అది దట్ విల్ నాట్ ఐడెంటిఫై. అది బై డిఫాల్ట్గా ఏ అంటే ఏమనుకుంటుంది సిస్టమ్? క్యారెక్టర్ అనుకుంటుంది. సో ద ఏ ఈజ్ ద క్యారెక్టర్. సో దీస్ పీపుల్ ఆర్ అసైనింగ్ ద కేస్ యూ కెన్ యాడ్. అండర్స్టాండింగ్ పర్పస్ చెప్తున్నాను. అది ఎక్కడైతే మీకు హెక్సాడెసిమల్ నంబర్ క్యారెక్టర్తో స్టార్ట్ అవుతుందో, అంటే ఏ టు ఎఫ్తో స్టార్ట్ అవుతుందో, దెన్ immediately you can write the in the MSB position 0. 0 left hand side add is the value change avutunda? Same ఉంటుంది. No change. So then you can add the 0. Now the system can understand. So, oh, this is the hexadecimal number. So A is the number, not the character. Okay. And some books are writing like this also. 0A, 2, 3, 6, H. Extension H అంటే ఏంటి అక్కడ? మనం అక్కడ బేస్ రాయం సిస్టంలో. ఎక్స్టెన్షన్ హెచ్ అంటాం. హెచ్ అంటే ఏంటి అక్కడ? హెక్సాడెసిమల్. సో యు నో you can able to convert the decimal to octal as well as decimal to hexadecimal. Convert binary to what? Octal. Binary to octal. What is the equivalent base value? 2. And what is the octal equivalent base value? 8. One is the binary to octal. Okay. R1, R2. Here also some, if you know what the any number, any binary, any number systems, if that number system is the 2 to the powers. Okay. So now, and R1 is equal to, okay, R2. Here, R2. R2 is right in terms of R1 powers. Right, Chama? What is the R2 value? 8. 8 can be written as 2 to the power. Okay. So the octal number system base value is 8 and 2 to the 3. 2 means just 2 each one. What is the 2? Box 3 value. Okay. So the binary value, what? 8 is equal to, how many? 3. Okay. So now 1, 1, 0, value. And binary value into octal number system or octal value in the binary numbers, you can group 3 bits as a one octal value. Group as B. This one is ML. Now, how many hits? 0. Now, octal value, octal and equivalent binary value. 0, 1, 2, 3, 4, 5, 6, 7. Right? Now, for that each octal symbol, you need to know the equivalent binary value. What is it? The number system can be represented in the wide format. 8 can be written as the 2 to the power 3. Because of that power, you can represent the each symbol of the octal value in the 3-bit format. Okay. Now, what is the one? 1 only, but you can add 0, 1. Then 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. These are the equivalent for octal values, octal symbols. Now convert 1, 0, 0, 1. This is the binary. So this binary value, write 1, 1, 0, 0, 1. You can group 3 bits as a one group. What is the value? 0, 0. See the table. Yes. Then you can add the how many digits are left, how many bits are required, that many zeros you can add at the MSB side, the most significant bit. Okay, that is 0, 0, 1, 1. Next, that value is 3. Okay, so now equivalent value is you. సరే కదా తెలిసింది equivalent, and this binary equivalent value is the 31. Now, one octal equivalent binary value, decimal value is మీకు బైనరీ number conversion from decimal number. What write the remainder separately until the quotient is 0. Then arrange the all remainders from bottom to top. Try to convert the 25 decimal to octal. ఎంత వచ్చింది 3 1 same. So now our division process is not required for you. Just you can know the decimal to binary and binary to decimal, right? Next, the binary to octal conversion is easy. How it is easy? By grouping 3 bits as a one group. And రిమెంబర్ దిస్ టేబుల్, ఇది గుర్తుపెట్టుకోవాల్సిన బైహార్ట్ చేయాల్సిన అవసరం లేదు. ఇవి కామన్ బైనరీ నంబర్స్, యూ హ్యావ్ టు నో. తర్వాత 1, ఆ 1 ఇక్కడ షిఫ్ట్ అవుతుంటుంది 1 0, దెన్ మళ్ళీ 1 1 ఫిల్ అవుతుంది, మళ్ళీ ఇక్కడ 2 ఫిల్ అయినాయి కాబట్టి ఆ 1 ఇక్కడికి షిఫ్ట్ అవుతుంది ఇక్కడికి. మీరు ముగ్గు పెడుతుంటారా, చుక్కలు పెడుతుంటారా, సేమ్ అలానే. ఆర్ యూ కెన్ నో ద డెసిమల్ టు బైనరీ లైక్ దట్ ఆల్సో. యూ కెన్ ద ఓకే. నెక్స్ట్ 6 1 6 ones 176. Okay, correct. Write the base 8. Don't forget to write the base. If you're not writing the base 8, then that 176 number value, decimal value. By default, that decimal ga మనం consider చేసుకుంటాం. So always write the base value of that number system. Okay, next. Equal to binary. How to convert? Octal is here, this one is 2, this, and it's same. R1 is equal to 2 to the power 3. But, and here, can go write each digit equal value in how to convert the octal to binary. Write the each bit of the octal value in 3-bit format. Okay, now the octal value 31 is the octal value. Write the equivalent binary value. Now here 31. Now this 31 is the octal value. For that one, write the binary equivalent value. What is the binary equivalent of 1? Don't write the simple one. Always, if the number is the octal, always write the binary equivalent for that each digit in the 3-bit format. You can remember that. Why we are taking the 3? Because the 8 can be written as the 2 to the power 3. And the 3, one digit of the octal is equal to 3 bits in the binary. That is the 0, 0, 1, and 3 is 0, 1, 1. Now, this is the equivalent. బట్స్ ఎలా ఉంటాయంటే మీరు ఎల్కేజీలో ఫస్ట్ నంబర్స్ని రాయాలంటే 1 2 3 అనేది గుర్తుపెట్టుకొని రాసేస్తారు. తర్వాత అడిషన్స్కి ఆర్థమెటిక్ ఆపరేషన్స్ వచ్చేవరకు మన ఫింగర్స్తో 1 2 3 రాసి 2 అంటే 2 లైన్స్ రాస్తాము, 3 అంటే 3 లైన్స్ రాస్తాం, అన్ని కౌంట్ చేస్తాం ఈక్వల్ టు 5 అని. అలా చేసిన తర్వాత సెకండ్ క్లాస్ థర్డ్ క్లాస్కి వచ్చిన తర్వాత నంబర్స్ రాయడం కానీ ఫింగరింగ్ కౌంట్ చేయడం కానీ మానేస్తారు. అంటే మీకు అర్థమవుతుంది ఏంది అనేది. ఆటోమేటిక్గా యు ఆర్ యాడింగ్. ఇక్కడ కూడా ఈ నెంబర్ సిస్టమ్ చదివిన తర్వాత నెక్స్ట్ వీఆర్ గోయింగ్ ఫర్ ద హై, somewhat moderate. Okay, so in that position directly you can say whenever I am saying the 6, write the 6 in the 3-bit format, direct conversion చేసుకుంటూ కూర్చోవద్దు. So next, this is the equal to binary. The next conversion is binary to hexadecimal, right? Binary to hexadecimal. The binary, say binary R1 base is equal to 2 and hexadecimal base R that is equal to 16 can be written as R2 is equal to R1 power 4. That is 2 to the power 4. Here, but now each hexadecimal symbol is equal to 4 bits in the binary number. That may be any value. So to hexadecimal, hexadecimal. And here 8, 9, A, B, C, D, E. I will write the sum value of. Okay, now uh, each hexadecimal value equal to one binary value is 4 bit. Why we are representing the 4 bit? Because the 2 to the power 4. Because of this 4, the each hexadecimal value is equal to 4 bits in the binary format. As 0 aina, you can write in the 4-bit format. There is a 0, 0, 0. Okay, next 0, 0, 0, 0, 0, 0, 0. Itma. Now you can write this. Write the 80. Everyone write the table. The table is the very, very important. టేబుల్ నాకు వచ్చు కదా అని మీరు ఇగ్నోర్ చేస్తే ఆ టేబుల్ కూడా మిమ్మల్ని ఇగ్నోర్ చేస్తుంది. అంటే మీకు అవసరం ఉన్నప్పుడు గుర్తురాదు. That groupism starts from LSB onwards. Only LSB. Don't take the MSB on. Starts from units place. That is the LSB, least significant bit. మళ్ళీ మనం ఏం రాయొచ్చు? 1 1 అంటే బైనరీ కావచ్చు, బి 6 3 ఇయర్. ఇక్కడ మనకు సోర్స్ ఏంటి, ఇన్పుట్ ఏంటి, ఆక్టల్. అవుట్పుట్ ఏంటి? సో ఇక్కడ మనకు తెలిసిన నెంబర్ ఏంటి, ఆక్టల్ ఓన్లీ. ఓకే, మనం ఫైండ్ అవుట్ చేయాల్సింది హెక్సాడెసిమల్. అంటే వాళ్ళు హెక్సాడెసిమల్ నెంబర్ ఇస్తారు, దానికి ఈక్వలెంట్ హెక్సాడెసిమల్ ఆక్టల్ నెంబర్స్ ఇస్తారు, దానికి వాట్ పాసిబిలిటీస్ అంటే ఎన్ని వేలు ఉన్నాయి, ఒకటే వెళ్ళొచ్చా, డిఫరెంట్ వేస్లో వెళ్ళొచ్చా? వెళ్ళొచ్చు, ఇలా వెళ్ళొచ్చు, మధ్యలో ఢిల్లీ నుంచి వెళ్ళొచ్చు, అట్లా వెళ్ళొచ్చు, అంతే కదా. బట్ వీఆర్ రీచ్ ద డెస్టినేషన్. ఇక్కడ కూడా మనకి ఆక్టల్ నుంచి హెక్సాడెసిమల్ కన్వర్ట్ కావాలి. మనం ఫైనల్ గా చూస్ చేసిన ఈజీ వేని చూస్ చేస్తాం, మనకు అండర్స్టాండ్ ఉన్నది, మనకి ఈజీగా ఉన్నది ఏదైతే మనం అనేది మనం ఫైనల్ గా విల్ చూస్. బట్ అకార్డింగ్ టు యువర్ నాలెడ్జ్, ఇప్పుడు ఇంతవరకు అయిన కాన్సెప్ట్ వరకు, హౌ టు కన్వర్ట్ ద ఆక్టల్ టు హెక్సాడెసిమల్. ఫర్ ది 69 టు ద ఏం డివిజను, చెప్పే కాన్సెప్ట్ డివిజన్ సంబంధం లేదు. ఎలా చేయొచ్చు, కొంచెం మీరు బ్రెయిన్ అప్లై చేస్తే వచ్చేస్తుంది. 16 లేదు కదా. Right? Process. The to this two and here. తీసుకుంటుంది. When uh, directly that octal value to binary. That binary convert binary to output for the. Okay, now here write the binary equivalent value first. Equivalent value. Binary equivalent value. The second step is group consists of the bit write the binary equivalent value in 3-bit format. The binary value, that binary value can convert by grouping the 4 bits as a one group. Now 0, sorry, 1, 1, 0, and 7 is 1, 1, 1, and 1 is 0, 0, 1. This is the given for 6, and the equivalent is this. Now, after getting this binary value, you can write the once again 0, 0, 1, 1, 1, 3 ones. This is the binary value. Now, to convert the hexadecimal, then 1, 2, 3, 4. One group, 1, 2, 3, 4. One group, ignore the 0. Okay, next, 1, 1, 0 ante E and similar the hexadecimal octal also. The same conversions. లంచ్ బ్రేక్ ఎప్పుడు 12 కేనా? Okay. Now, any doubts in this number conversions? Okay. Simply మీకు ఏం కన్వర్షన్ రావాలి బేసికల్గా డెసిమల్ టు బైనరీ, బైనరీ టు డెసిమల్, డెసిమల్ టు బైనరీ, బైనరీ టు డెసిమల్. ఆ రెండు కన్వర్షన్లు వస్తే దెన్ దిస్ రిమైనింగ్ కన్వర్షన్స్ ఆర్ ఎవ్రీథింగ్, ఎవరీ కన్వర్షన్ ఈజ్ ఈజీ. మీకు డిఫరెంట్ నెంబర్ సిస్టమ్ టూ టు ద పవర్ కాకుండా డిఫరెంట్ నెంబర్ సిస్టమ్ తీసుకున్నాం అంటే అది మళ్ళీ డివిజన్ మల్టిప్లికేషన్ ప్రాసెస్లోనే ఉంటుంది. బట్ వీఆర్ నాట్ గోయింగ్ ఫర్ దట్. మిమ్మల్ని టెస్ట్ చేయాలంటే వాడు ఒకవేళ 6 నెంబర్ సిస్టమ్ ఇచ్చి బైన్లోకి కన్వర్ట్ చేయమంటాడు, లేకుంటే డెసిమల్లో కన్వర్ట్ చేయాలి. అప్పుడు మాత్రమే 6 పవర్స్తో మల్టిప్లై చేయడం కానీ 6తో డివైడ్ చేయడం కానీ చేయాలి. అంతే. ఒకటి బ్లైండ్, ఒకటి గుర్తుపెట్టుకోండి ఇక్కడ, డివైడ్ విత్ 8. ఆ డెసిమల్ నుంచి హెక్సాడెసిమల్ కన్వర్ట్ చేయాలంటే 60. డెసిమల్ నుంచి 6 నెంబర్స్ కన్వర్ట్ చేయాలంటే 6. 9 నెంబర్స్లో కన్వర్ట్ చేయాలంటే డివైడ్ విత్ 9. బట్ అవన్నీ ఉండవు కాన్సెప్ట్. ఓకే, అది అంతే. ఈ ఎందుకంటే ఇది లాంగ్, ఇట్ విల్ టేక్ ద టైం. ఎవరికి 16 టేబుల్ కూడా సరిగా రాదు. గుర్తుంది ఎవరికైనా? గుర్తుండదు అది. 8 టేబుల్ వరకు ఓకే, 8 9 వరకు ఓకే, బట్ 11 ఓకే, 12 తర్వాత అందరు కన్ఫ్యూజ్ అవుతారు. ఎందుకంటే అవి యూజ్ చేయట్లేదు. ఎందుకు యూజ్ చేయట్లేదు? స్మార్ట్ ఫోన్స్ వచ్చాయి. 2 ఇంటూ 8 చేయాలంటే కూడా క్యాల్సిలోనే కొడుతున్నాం మనం. ఇప్పుడు ఎవరు మాన్యువల్గా చేయట్లేదు, మన బ్రెయిన్ అప్లై చేయట్లేదు. ఎందుకంటే మనకు సోర్సెస్ అవైలబుల్ ఉన్నాయి. ఎప్పుడైతే సోర్స్ మనకు అవైలబుల్ ఉంటుందో బ్రెయిన్ అప్లై చేయం. మీకు అంటే మీ ఏజ్కి ఫోన్ నెంబర్ దాదాపు మీ మదర్, ఫాదరు, ఇంకా బ్రదరు ఒక 2 3 నెంబర్లు తప్ప ఎక్కువ గుర్తుపెట్టుకోలేరు. బట్ 2000లో 2000 ఆర్ అప్పుడే మొబైల్ ఫోన్ ఇంట్రడ్యూస్ అయింది, అంటే 90స్లో. అప్పుడు ప్రతి ఒక్కరూ 50 to 100 నంబర్స్ నోటెడ్ ఉండేవాళ్ళవి. బ్రదర్కి ఫోన్ చేయాలంటే టక్కున నెంబర్ కొట్టేవాళ్ళు, ఎవరు సెర్చ్ చేసేవాళ్ళు కాదు. ఇప్పుడు మనం ఒకసారి సేవ్, సారీ, నంబర్ కన్వర్షన్ తీసుకున్నాం. Binary information. That is the data consists of information only. Binary information. Space. And the characters are 256, including small case letters, capital case letters, and numbers, symbols, comma, space, hash, at the rate, star, plus, ఒక్కొక్క దానికి ASCII value ఉంటుంది. Now, think the which standard of course ASCII presentations are there. ASCII, EBCD, IC. Anybody can tell me the ASCII full form? American Standard Code for Information Interchange. Correct. Now, think inter for interchange code. Interchange code. Okay. So now 40 and quantitative. The data can be qualitative, quantitative. Now Quantitative, quantity, how much? Simply how much? The numbers. That is a how. What is the strength? 20, 40 members. That is the 40 is the quantity. And how is the class? Good or bad? Is the quality. That is the quality. So the data can be represented in the quantitative and qualitative. Examples are small, big, next short, long, the different features. Next, quantitative, how much? What is the class? How much the building height? The 30 meters or 40 meters, 50 meters, like that. Okay. So that is the quantity. The quantity again. So that means num numbers. So the number using 8 బిట్ అన్నారు అనుకోండి 0 to the power -1 ఎంత? నేను సార్ టచ్ మైనస్ 3, 4, 5, 6, 7. దీనికి ఏం పెట్టచ్చు? 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1. In we can ask 1, 1, 0, 1, 1, 0. We can assign the 8-bit register. Then దాటితే we can't. There is a drawback. We'll understand the drawback of. Okay, that numbers can and their information you required. The numbers can be represented in 8-bit format, bit or 6-bit or 10-bit or okay. So that it may be positive or negative. To represent the number is positive or negative, the the sign bit. Position sign bit కి ఇచ్చాము only one bit. The remaining 7 positions for the match. ఓన్లీ బైనరీ నంబర్స్ జీరోస్ వన్స్ మాత్రమే గుర్తుండాలి ఇంకా ఓకే మధ్యలో మధ్యలో డెసిమల్ గుర్తుంటే వస్తే ఆ డెసిమల్కి ఈక్వల్ బైనరీ వాల్యూ స్ట్రైక్ కావాలి ఇమీడియట్గా స్ట్రైక్ కావాలి ఓకే సో sign bit in this sign bit we can place either 0 or 1. 0 means no means లేదు సైన్ లేదు బై డిఫాల్ట్ పాజిటివ్ నెంబర్ పాజిటివ్ నెంబర్కి వచ్చి 8 బిట్ తీసుకుంటే be written as